the subclass. So we effectively were imposing the relative constraints on the subclasses. And all the contracts, again, can be monitored at one time. That's really useful thing, or valuable thing for iPhone. Okay, so we'll talk about substitutability in more detail today with some examples. Okay, open close principle here. So that would be by inheritance. And now we also talk about, from the module point of view, from type point of view, you can read this. It's a little bit boring here. Okay, so we have different terminologies for inheritance. I believe you know most of them already. The only thing I would like to mention again is the notion of base class. So basically, remember the class hierarchy I drew last time. So let's say if you have a smartphone, and we have some inheritance here. Let's say we simply have iPhone. Okay, so that's the bird, we have this, and let's say that's Samsung. Okay, so this is the class of the hierarchy you have for your smartphone. So you can only create instances for iPhone or from Samsung. Okay, so now if you have in your code, if you declare, let's say I have P1, phone 1. If I say phone 1 is declared as type smartphone, so this is so-called the base type. This is called the base type for your P1 variable, okay? Or you can call it static type. That's another thing. So what this will constrain on the later usages of P1 is, let's say later on if you're trying to use P1, let me make some example here. So let's say, of course, smartphone you should be able to call, let's say, and you should be able to maybe, let's say, check email. Here, and let's say we can all defer. Okay, let's say these are the only two features. But now, we'll add more later. Let's say for iPhone, certainly you have to make the call. When you make the call, you have to make it effective and also check email. Similarly, you have to make it effective and similar for Samsung. So let's say now for iPhone, since they're using iOS operating system, they might have something to say, let's say play iTunes. Yes. For Samsung, these things they're using Android. So, for example, you can say open, for example, Firefox or whatever, or Chrome web browser. Yeah, just some feature that may not be supported by the other one. Okay, so now you can see that if later on, let's say somewhere in the code, so if we say P1 dot play iTunes list. My question for you, will this compile or not? If you think that will compile, why? If you think it will not, why not? You think it will compile? Okay. Anyone who think that will compile as well? Or you think that will not compile? Okay, actually this is nothing new because you should have known that already from Java course. Okay, so this is actually something we also talked towards the end of the lecture. It's something called static item. Okay, so basically, let me just move this feature over a little bit. So as we open Firefox here. Okay, so knowing what the base type for a particular variable is very important because that's the only information that the iPhone compiler gets in order to check to see if this particular feature call is valid or not. Basically, what the iPhone compiler would do is to say you might have done some very complicated coding before you reach this line of code. So iPhone compiler usually is undecidable for the compiler to figure out what exactly have you done in this particular fragment of code before you reach here. So the only information that iPhone compiler gets is to see what's really the base type or the static type for this particular variable. In this case, it's actually smartphone. And then it's going to check to see if play iTunes list is actually some feature that's actually defined in a smartphone. In this case, it is not. So that means this would not compile unless you do some test. That's another story about what you want to say. If you write it like that, it wouldn't compile. Because, again, the base type is the only information the iPhone compiler will get. In this case, it is smartphone. And in that base type, it does not define this play iTunes list feature. So now on the other hand, let's say I have P2 here. If I say iPhone, okay, if I say P2 dot, let's say play iTunes list. In this case, again, all the iPhone compiler would know is that the base type of this variable here is iTunes. So I would check, iPhone compiler would check to see if the play iTunes list is actually defined in this particular class. It is. So this line will compile. Okay? Another quiz for you. What if I say P2 dot check email? Will it compile? Why would it work? Why would it compile?
Because it has check email.
Why does iPhone have check email feature? Because you can see here, we have P2 here. The base type for that is iPhone. But here, we don't really have check email here. So why would it compile?
Check email.
Sorry, yeah, actually, sorry. Usually, sometimes they don't show, yeah. Sorry, that's a silly question. So in this case, yes, it will compile. Yeah. Wow. You gotta forgive me, I only got one banana for dinner. Okay, anyway, so in this case, yes. So this P1 dot play iTunes list will not compile, and this would compile, and this would compile. Okay, make sure you know why, especially for this line of code. Because, again, all the iPhone compiler would know is what the base type is for each variable, because it's an undecidable problem to figure out what a particular fragment of code will actually do, that you learned from the 2001 course, right? Okay, this is a very important concept for static typing. We'll revisit it later on in the lecture. All right. Okay, so we're going to talk about polymorphism and dynamic binding. And polymorphism is really about how you can reassign, the variables to different attachments. For example, so here, let me use the same example here. So now, because P1 is actually a smartphone, so let's say if I say P1 is assigned to be P2, that means currently I want to have a smartphone. I don't care which one it is. So now if you give me an iPhone, I'll be happy. That's fine. So let's say we have P3. Let's say it's a Samsung. And if I say P1, again, my phone, if I say that's assigned to be P3, this will also compile. Because now, all I really care about is the smartphone. I just want to call and check email features for my own purposes. So if you give me either an iPhone or a Samsung, doesn't matter. Both are equally good. And the fact that you can actually change the binding, or you can change, okay, so let's say this. So let's say P1, so this is P1. So this is some objects of type iPhone. Okay, so this is another object of type Samsung. Okay, so when you're doing this assignment here, basically you're saying, instead of attaching to this, I'm going to make P1 attach to that. So this kind of reattachment to different objects, but of the type that are actually somehow consistent with each other. When I say consistent, I mean they're both the subclasses of the same superclass, smartphone. So this is called polymorphic assignments. So that's really what polymorphism is about. Okay, so this is really polymorphic assignments. Okay, right. Okay, and then dynamic binding, in this case, will be also simple to understand. So here, so because now we are changing the shape of P1 from smartphone into Samsung. Let's say in between the changes, let's say now, if we say P1 dot check email, here we're saying P1 dot check email again. You can see that we are really calling the same feature. However, the behavior for the same feature call will be different because they are called in a different context. When we are calling this P1 check email, the first call here, basically the check email, how the check email is going to behave depends on how the check email is defined in the iPhone, because that's a current attachment for P1. And then after we have delete this link and then make this new link, now when we try to call the same check email feature again, it's actually going to call the check email feature here, the Samsung, because that's inherited from the smartphone. So they must have implemented that. Okay, that's dynamic binding, basically. So you should really be able to understand this kind of like a general definition for polymorphism and dynamic binding. It really summarizes the assets for the two. So polymorphism allows you to change the shape using assignments for different attachments. And dynamic binding is going to say, depending on the current shape of your attachments, the objects, although being called the same feature, is going to behave differently. Okay? So I think using the example, you should be able, should be easy to see. Okay, so this is, I think that is pretty much where we ended up with. So let's say now we are trying to do an array of figures. And now the figures basically have different shapes of the figures. And you have diamond, you have polygon, you have star shape, you have even 3D shape here. So so this is actually one way of using it. Remember you have learned the generic parameter already before your midterm. So this is actually a very bad way of instantiating the generic parameter. Remember in the array class, so if you have a look at the library definition for that, you actually have class. Here we have array of G. This is how you declare the array class. So now you're trying to use it. So you're saying figures is an array of something. And that something has to be instantiated by some type. So here we're saying that's simply any type. Anything will be fine. So this is actually very bad, as we'll see, because you're not being very specific about what the figures are really storing. You can even store some persons, or even store a stack, or anything you like, or a string into the figures. So the ultimate solution we are trying to build up is to have just the right type, such that you can store, like here, figures only. That's the intuition you have to get. Okay, that's the problem we are facing. So now, see here, we have a rotate feature to increments. So here, the rotate feature, let's see how the rotate might be implemented. So here, because we simply have a figure which we know nothing about its type, because you can see here, we simply have any. Okay, so the any type can be a circle, can be a polygon, and can be something else. Okay, now let's imagine this. Let's say, for the figure, you might do different operations on the figure, right? So you might want to, so operations or features on the figure, operations on figures, okay? So for example, rotate is one example there. Also, you can display. Okay, you can also move. Okay, you can also move your move your figures, or you have different operations you might perform geometrically. Okay, so now my question is, what do you see as a problem here? Let's say for the rotate feature, we're implementing this way. Because f is the most generic type we can instantiate, is simply any. So we have to check to see if currently, if the shape, if the figure is actually a circle, then we will rotate this way. If it is a polygon, then we'll rotate this way, depending on what shape it is. What could be the potential problem for this? Okay, a hint would be to consider what are the possible operations for figures. Let's say here I'm only giving you 3 examples. Let's say you have 10 or 20 or tens of operations to implement. Then what can be the problem for this if you have to follow this pattern? For each operation, you have to repeat basically the same pattern of code, repetition, right? So whenever you have repetition in your code, that means you better consider to actually have something that, have one thing that can handle all of them somehow. Okay, this is a spot on observation there. So basically, so now, all other routines, for example, have display there or move, all the features, they have to basically follow the same pattern here. So they have to check, because f figure is simply any type. So I have to check to see what exactly that figure is. Okay, so now let's say we have this many features here. So now consider this. We're trying, because remember the open close principle. We want to be open in order to extend the kinds of shapes we might have. Let's say currently, if we simply have, let's say the shape here, we have these shapes are already known to us. But let's say we want to create a different shape. Let's say pentagon, which is not there. Let's say we are trying to add a pentagon shape into our category. What's going to be required to change? If we actually add a new figure there, what we have to do is, for all the operations there, we have to add like an else if branch to say, else if the figure is actually a pentagon, then we have to do the corresponding operation. Okay, that's basically the problem for that. So basically, you are trying to repeat the same pattern of checks all over your developments. That's really a bad design practice. Okay, so what we really need is to try to abate the single choice principle. Okay, that's the basically another principle for you to learn. So we have learned so far the open-close principle, and before the midterm, we have uniform access principle, and we have information hiding principle. We have command query separation principle. And it's too bad I didn't ask any question about them. Only information hiding. Yeah, maybe I should, right, in the final. No, okay, yeah. Right, for single choice principle there, yeah, so let's try to learn that. So that single choice principle is exactly the criterion to help us get rid of that kind of bad design. So whenever a software system must support a set of alternatives, in this case, let's say we're trying to support different kinds of figures. Let's say it can be square, it can be pentagon, it can be polygon, it can be rectangle, whatever, okay? So here, one and only one module in the system should know their exhaustive list, okay? For example, let's say here, if you see that, so this is one exhaustive list for all the possible shapes that we're currently supporting. But let's say, for all the other operations, we have to repeat the same list over and over again, right? That's really the bad thing. That actually violates the single choice principle. That's really something we want to avoid. Okay? So later, if any variance, when we say variance here, if we are trying to add a new figure, so we only have to update a single module, the point of single choice. We'll see how this can be realized by using polymorphism. Okay? So somehow the single choice principle is related to the open-close principle. But how? Okay? It's open and closed. So open because we want to actually add new alternatives. In this case, we can always add a new shape into our vocabulary. Okay, that's the open part. And the closed part is we should really maintain just one single module for the point of single choice, and that part should remain stable. Okay, that one shouldn't really change that constantly. Okay, that's how it is related to the open-close principle. You think about this principle. We don't really have much time in the lecture to let you think. You should really do that outside the lecture. Okay, so we do need a new solutions there, rather than saying array of any. But how do we do that? So we want to be able to add new kinds of figures without modifying all the features that operate on the figures. So how do we do that? Solution will be exactly polymorphism and dynamic binding. So in some way, this idea is really, again, not new because we learned that from the Java course. So that part is really consistent with Java. So let's say we have this inheritance hierarchy here. So we have figures, and we have closed figures, and under closed figures we have polygon and ellipse. Let's say here for the figure, we actually try to support different features here because for example one of them is display or also rotate. And for the closed figures, it makes sense to calculate their parameter, the size added up together. And also, you can see that the subtle difference is in the closed figure, the parameter there is actually deferred, which means it's not defined yet. And are you coming back? Okay, so now for polygon, so here you're trying to make it effective. So now in the polygon, because somehow it actually has different size. Okay, for the closed figure, we don't exactly know how the shape would look like. That is why we make it deferred. But for the polygon, so it can be rectangle, it can be a pentagon, or it can be hexagon, etc. So for each one of them, it's a very easy way to figure out the parameter, because simply just add up all the sides together, right? And okay, that's basically the issue here. So here you should really know the notation for start and plus. Okay, so just adding more shapes into the hierarchy here. You can also overlay yourself. What I want to draw your attention to is the plus plus. Okay, for example, you can see that for the polygon here, you can see the parameter there is simply plus. And here in the square we have plus plus. Okay, there's a very important difference here. So here, we say start is first. So plus is to say effective, and plus plus is really important. Okay, so here we're saying in the closed figure class, we are not really sure what kind of figure you have. We only know it's a closed figure. So we actually just keep the definition deferred. We don't actually commit to any definition just yet. But now, in the polygon, we actually have a very generic definition. So it doesn't matter what kind of polygon you have. You must have a finite number of sides for your figure. So we simply just adding up together. But now for the square, we actually have a more efficient way to define the parameter, which is once you know the length of one side, you can just multiply that by 4. So that's called redefinition. Okay, that's a very simple example to illustrate the 3. Okay, so later on, if you want to actually draw the architecture diagram, you should really think about whether you should put a star, you should put a plus, or you should put a plus plus. Okay, you should really be clear about that. Okay, so now, since we talked about open-close principle, for the open part, it's really about how you can extend your examples. So now, let's go back to our example here for the figures. So basically we have
alternatives. Okay, so also we have the operations that we might apply to the figure. So here, so we have maybe we have square, we have circle, we have some pentagon or etc. Okay, and for the operations, we might have rotate, and you might have the parameter. Also, you may have display, and etc. So these are two different angles of looking at your our particular application scenario. Okay, now when I talk about open-close principle, we are really saying we might actually our software is actually open for extension. So when we say extension, we might extend either the kinds of figures or we might extend the kinds of operations either way. Okay? So when I say if I want now to extend the kinds of figures, I might, for example, add a rectangle into it. So whenever you do some extension to your software, what you got to think about is what's going to be the effects to me? What's going to be the coverage? What's going to be the extent of change I have to make to my existing software? If it is actually has to be very huge, that might mean my software was not maintainable enough. And also for the operations, let's say other than rotate, parameter, display, I might just have other operations, just you can imagine. Okay, so now, typically, the single choice principle cannot be satisfied for both. Okay, that's something I want to show you. That's something for you to think about. So now, as I said, you might add either a new figure or you might add a new operation. Okay, so which one will actually obey the single choice principle and which one will not? That's something we gotta see. Okay, so now let's say let me show you actually before I go into it. I want to keep this because I'm going to use that. Maybe I'll erase this. Okay, so let's say we have a figure here. This is like a simplified version of the cross hierarchy. Okay, figure here, and then let's say we simply have a class called square. Then we take two existing classes, let's say square and also we have the circle, for example. Okay, let me just make it easy. Let's say we have already some feature here called display. Okay, just one operation. And let's say here in the square we must make it effective. So we have display being effective here. And now we also have our circle defined for the display feature. Okay. So now let's say this is already here. This is the existing development for your account. Now let's consider the two possible extensions to your system. Let's say if you're going to add a new shape, how is that going to change? Is it going to affect a single module or make a single class, or it is going to affect multiple classes? Oh, I heard some single there somewhere. Yes. Why? Yes. Yeah, figure. Yeah. So what will be the change? Okay, let's say I want to add a rectangle. So where should I put the changes? Okay, so you gotta be more specific. So let's say this is our architecture here. So what should I change if I want to add a new figure here? Let's say rectangle. Draw, okay. You need to actually draw maybe a rectangle here. Rectangle here, and then okay, maybe inherit from there, and then of course in this rectangle here you must supply the implementations for all the features or all the deferred features that you actually inherit from the figure. Okay, in this case, just display. Let's say you have actually a list of operations that you actually inherit from the figure. But that's okay, because there's only one single class you have to touch, which is the new figure you're introducing. So this one, as far as the single choice principle is concerned, is okay, because there's only one module or class here that will actually implement all the existing features that must be supported for figure. Okay, this is the case where the extension would not violate the single choice principle. That's extension number one. Are you okay with that? Okay. Now, what about the second extension? What if we want to add a new operation to the figure? Let's say, rather than display, let's say we have display already. Let's say we want to add a new operation here. Now we say rotate. Now, what's going to be the cost of making such a change? Is it going to affect multiple modules or just one single module?
Multiple.
Why multiple?
Because the rotates are not the same, like that implemented each one.
The rotate has to be implemented in each figure, right? Yeah, so exactly. So now for rotates, we actually have to implement the rotate here, and also rotate here, and rotate here.
Do we have to implement it for square?
Yes, you have to, because rotate didn't exist before. Since you actually said the square is actually a effective class, so everything that's inherited from the figure that is deferred must be implemented. Yeah, so for every class. Okay, you can see now the two kinds of extension. One would actually violate the single choice principle, and the other one would not. So a possible exam question could be, I describe the example to you, and then I ask you, I tell you that there are actually two possible extensions you might do. Which one would actually violate the single choice principle? And why? And that should be considered as an easy question, I believe.
I'll write it for you.
All right, so these are exactly just what I said in the example, so please make sure you understand the example, and then you can read through the descriptions again. Okay, so here it's about redefinition, how you do it. It's also exactly what I said. So this is actually the parameter feature here for the polygon. And because for polygon, we don't actually know how many sides exactly we have for polygon. So we simply just run a loop to actually add up the sides together. And now, if we actually go to somewhere that's actually more specialized, let's say we are now in the rectangle, which is like a more specialized version for polygon. In this case, we can redefine, which is the plus plus I just mentioned. Redefine parameter by saying, now to actually calculate the parameters for polygon, for rectangle, I simply just add up the two sides and multiply by 2, right? Okay, polymorphism. So what the ultimate solution is, rather than having any here, so we should put something that's just about right. Something that should be specialized enough. So for example, if we put figure here, that wouldn't allow us to store smartphone into the array. And that wouldn't allow us to store person into the array, but only figure and also figures descendant classes will actually be allowed. So in this case, let's say we have, so you can see triangle, rectangle, and ellipse. So these are the base types for these three variables. So if the base type is actually a descendant class of the figure, then you will be able to store under that array. Okay, that's really the rule. Let me write it out. Okay, so let's say, so you have figures, which is an array of figures. So now, given this declaration here, we can say figures may whose base class is a descending class of figure. Okay, so you really have to know what's the definition for descending class, and that's really in the beginning slide we talked about before the picture. Please look it up if you forget about it. Okay, that's really the constraint for static typing. So now, so that's why all of these would be allowed. So here, because we are trying to expand the array, so that's why we are using force. I think in the midterm, quite many of you actually trying to use almost right by using put rather than force. So the difference between put and force is put wouldn't allow you to expand the array, but force will be. Okay. Yes. You have a question?
But the test, you have the array that's already
In the what do you need a force? Because if you're trying to dynamically expand the array, you have to use the force. Okay, let me show you. So just imagine that. So you might, I think that will be very important, although it's like a programming detail for ISO, but you also need that in your project, I think. So it's really about force and code. Let's say you have some array here, let's say currently with 3 elements here. So you need to have index lower being 1, upper being 3. Okay? So array A. Okay? So if you say A put, and then so you would say put A in position 3. That would be easy. You simply put A. You will simply put A over here, and that will be the corresponding updates. If you say A dot force, and then do the same argument, it will be the same. Now, what's really going to make a difference between force and put is, let's say, somehow I want to expand the array. Let's say I'm trying to find out all the names in the book that actually share the same birthday. So I have to dynamically expand the array. If I say A force, and then I would say B, for example, and then A dot upper plus 1. So we know that A dot upper is simply 3 in this case, right? And A dot upper plus 1 would be 4. So 4 currently is not really a valid index for the array. But because we're using the force feature, so it is going to actually do some extension for the array. So we're going to create a new position for the array. That's going to be 4, which is equal to A dot upper plus 1, and then we'll put B over here. Okay, that's what the force will do. But if we say A dot put, let's say we're trying to put C, and then A dot upper plus 1. What this will do is to give you some counter violation. Because for the put feature, always the index you put must be a valid one. But for the force, it can be one off the current boundary, in which case it will actually expand the array. Yeah.
Whenever you return an array, you have to use the force.
I would say basically, yeah. Whenever if you have to extend your array dynamically, you have to use force. Yeah. Yeah. So that's a very important difference. You know? Yeah.
For this question, if I use the A dot upper plus 2, is this okay for force?
No, it will not be.
Oh.
No. Just one off. You should really try, and then let us know tomorrow. Yeah.
I actually tried doing +2 and it gave me an error called default not found, something like that.
Okay, you know what? Okay, very good. Okay, it's good that you mentioned that. So you did do your homework. That's good. So let's say if I say A dot upper plus 2, 4. Okay, what that means is we're going to put 2 things over here, and then let's say we're going to put something here, E. But what to be put here? We don't actually specify the voice feature. Let's say if the voice safety is already turned on for your projects. So the void safety will actually require this, if you actually don't put anything here, by default you'll be void, but it cannot be void. So the thing you're trying to put here has to have some default value. That's basically what the issue is. So yeah, if you have no idea what I'm talking about, you should really go back to your tutorial. Okay, that's like a little bit sidetrack. So we have polymorphic assignment here, so make sure you know how to use force. And then we have dynamic binding. So now, whenever we get some figures back from the, we get some figure back from the figures array, and we can simply just call the rotate feature. Now this F here, the base type is simply just figure, but the dynamic type can be square, can be circle, can be any other kind of figure that's defined. And the rotate, how the rotate is going to behave depends on what's the current binding, what's the current shape of the figure. Okay, so that's the dynamic binding here. Okay, why don't we take a 5 minute break?